Hello everyone, welcome to the next session on ABAP on HANA. In the last class, we have discussed about join types, analytical views, using import parameters in analytical views, calculated and restricted columns in analytical views, and also we have seen how to create an analytical view by using different join types. Towards the end of the class, we were also able to create a sales analytical view which joins the data with the product dimension with the fact table as a sales table, and were showcasing the data in aggregated form. There was also a problem which we observed, that the data which was previewed in analytical view in form of graphical representation was not matching with the data with the product which we calculated from ASQL query. I will tell you the reason for that, and then I will correct this issue in the system by creating another analytical view and show you the result correctly. So let's quickly run our data preview once again for this analytical view for sales. I just put the product ID on the label axis and also the final gross amount in the value axis for calculating the aggregate. So you can see HT1000, the calculated value is 262,862,674. So 262,862 was not matching with this, the value which was displayed here. That was because the aggregation was calculated based on the column gross amount on header table. Let me quickly show you the structure of the header and item table, how it is behaving, why it's not giving us the correct result. So I will quickly draw the header table. So what we have in the header table is the order ID and the gross amount of total order. So this is your order header table. So if I just quickly draw the information, what is this table all about? It's the order header table. So you have a order ID, you have a gross amount here. Yeah, so this is what we have it in the header table. I just delete this additional column. I just put here, let's say order number 1 gross amount is 1000, 2 2000, 3 5000. This is your table. And then you have an order items table which contains the information about the product which was sold during that order. So I will just introduce the new column. And so you have here the line item, then you have the order ID for which the line item exists, the product which was sold, and the gross amount for that each product which was sold. Yeah, this is the table what we have. So if I try to input some data over here, so you say line item 101, 102, 103, then maybe if I just introduce some new records quickly, just say 201, 202, 20, or just say 301, 302, 303, 304. And let's say these are for order number 1, order number 2, order number 3. So that's the data we have. And then we have the product information, let's say PRD1, PRD2, PRD3, PRD1, PRD2, PRD3, PRD2, PRD1 again, and let's say PRD4. And then you have gross amount as, let's say, 500. Then we have 300, 200. And then for 201, it's, let's say, 1000, 1000. And for this, let's say it's 2500, 500, 1000, and 1000. So this is the data what we have. So if you look at here, the order header table and order item table, the order item table actually was containing the information about product sold and what was the gross amount produced by each product. So if you see here, the gross amount is the gross amount of total order. Okay, so if you see, there were three products sold in the first order. You can see here order number 1 is the foreign key relation, and you see order number 1 here. So there were total 3 products which were sold. So these are all the 3 products corresponding to order number 1. Then these 2 products were sold corresponding to order number 2, and these 4 products were sold, or these 4 line items were sold with product number 3. So for each product, if you want to calculate the total sales, you should sum up this line, let's say for product 1, then from order to this line, and for product 1 again this line, rather than getting the gross amount from order. You should get it from order item. The gross amount which should be considered in your view will be the gross amount from the items table, not from the header table. But what mistake did we do is we have considered the aggregation from the header table, which is incorrect. That's why you see a difference in the values. So now we will consider the gross amount value from the items table to be able to derive the exact result, which will also match with our query. Let's go ahead and do that. So what I'm going to do is now go back to the system and go back to our analytical model, go to data foundation, and in the data foundation I will exclude the gross amount which was picked up from header table. I would just remove that from the output. So let me just do that. Okay, I don't see the output over here being considered at all. Can I remove it? I don't see the output columns on the left hand side. Ideally it should have showed me all the output columns. Let me close the view and reopen the view again. So I double click on the view once again to see the provided output columns from my data foundation from the fact tables, and there I should include the gross amount field from the items table rather than from the header table. That's the main intention. So now you see it shows me the data from both the tables, and I can see now the columns. So the gross amount which was selected here was from the header table. I should change it. So right click, remove, even including the net amount. So now it's saying that it's participating in some kind of aggregation. That will also be removed. I'm fine with that. I should consider all these values right from the items table, but not from the header table. Let me just remove this currency code also, which was used in currency conversion. So all that references it's showing me. Now you see this is my data, and those columns are now been gone, and I just pick it up from gross amount, net amount, tax amount, per item level with the currency code. So these are all the values I have now selected: gross amount, tax amount, net amount from the items table rather than the order table, because that's the right way of calculating the right aggregates. Go back to the star join. This join won't get affected because of this. That's absolutely okay. But our currency conversion would have got affected. So in the calculated column for gross amount in INR, we would see go to semantics. So this gross amount has to now come from the items table. So I select columns and then just choose the gross amount. Here it is. Go to semantics and just also select the gross amount from my items table. That is, sorry, currency has to be from the items table. The currency code is here that I choose. The source currency will also come from it because it's based on every record. So say column, and then again it has to be according to the currency code here. And then output currency is my import parameter. That's absolutely fine. Generate the result in the new column. This is also okay. And any currency conversion failure, ignore it. We are good. We adapted the model now. I'm just gonna click on activate, save and activate the model. And if there's any issue, it will tell me now at this point of time. So let's click on save and activate the model, and then we will get to know if there is any problem. It will tell me in the bottom log if there's a problem in the model. And then now we will find out an aggregated value of gross amount per product. Yeah, and that we will compare it with our query. It should match. Let me also keep my notepad ready so that I can match the value. So maybe from model, what will be the value for HT1000? We're going to write down here and compare it this with the query value. Let's quickly do that. Okay, there is an error, completed with error as expected. Double click and find out what's the issue. It says encountered an error, no base measure no base measure for restricted measure value software. So I think now since we have changed the measure fields, it has completely removed the measures. So go to semantics and also mark our new measure fields. So this is some measure field. Okay, all the numeric fields I want it to be measure. So value software, and then this gross amount should be a measure, net amount should be a measure, tax amount should be a measure. All three are my measures. This was the problem. I click on save one more time and just go ahead and say shoot. Okay, so let's do that. So let's say it's running now again. Let's see what will be the result. You can see this time completed with warning. So we are good. And let's quickly have a look at the data preview now. For a product wise gross amount total we want to calculate. So that should be the right result. We will get it now. Let's pass the currency value as USD itself. I don't want to convert anything. Click on OK. And I got the data. So product ID. Let's quickly check the raw data if some data is being displayed. If join works properly, you see the data is populating, which means seems to be okay. Let's now do the aggregation product ID based on the gross amount, which is now being taken from the this table. And now if you look at here for HT1000, let's see the value. I just hover my mouse. It's not showing me the value. Yeah, 296,08218, 29,608,218. This is the value which I've got it from the view now. And now if I go back and check this, you can see the value 296,082,082 and 1818. You see, this is how we catch the problems. So the last example, since I use the gross amount column from the header table, it was just giving me the data from the order header table, this gross amount. So even though there was just an entry it was finding, it was totaling the gross amount of orders. But ideally I want it with the perspective of product. So now it's giving me correct data. So it is summing up basically all the data based on product, this value, and this value. Wherever it finds PRD1, it's summing up that value. Earlier what was happening, if there is an you can see in first, second and third, all three orders there is a product. So it was taking the product, picking this value for the fourth one, again this product, picking the value this one from fourth one, second one this product, finding a record, picking this value, summing up these three values actually, which was incorrect. It was giving me actually an order total in which my product is part of the order. Those order totals it was giving me, but my requirement is to calculate the total amount for the product. Okay, hope this is clear to all of you now. This value is also matching now with your query. So that's how you validate your data. Okay, so yesterday due to lack of time I did not changed it because I wanted to close the class on time yesterday, so I did not change it. But then again I realized that it's good if I show you this validating our query. So the query data should match with the data from the data model. You should not represent or you should not supply wrong data, because it's all about data interpretation. Technicality is one side, but ultimately business expect you to provide the right data as per the example. So example says I want to design a star schema to find total amount of sales and purchase for each product wise they want it. That's your requirement. So not order wise, they want it product wise. Yeah, so that's what the right output is. So let's do now same thing for a view which we will create now for the purchase orders. So this one is for sales order. Let's create another analytical view for purchase orders. So I would right click now on analytical views and try to create a new analytical view for purchase facts. So I just say analytical view, purchase facts, and then I say my star schema for purchasing data. It's a product dimension which I am considering here mainly, and say finish. This would lead me to creation of a new analytical view, just the way we were yesterday creating our the another view. So let's do that. So there you go. You can see now analytical views. Let's prepare the data foundation for the same. I'm going to quickly add the tables for purchase order. So SNWD underscore PO. These are the tables which have purchase order and purchase order items. You see both are from SAP A4H schema. Make sure that schema selection should be correct, guys. So you may have multiple schema where the same table may exist, because schema also provides a namespace at the database level. So you may find same table in, maybe if you're using local HANA DB in your company, you may find same schema, same table in another schema also. So be little careful. You have to make sure that in the parenthesis the schema name is displayed. So that's the correct schema you should choose from. Okay, so that's my schema. Now I selected these two tables for purchase fact, and then I'm going to join them, and again consider the gross amount from the purchasing data. Okay, just to do that, just put them side by side and just define the relationship, node key with parent key, and it's a referential constraint with 1 to n cardinality. Click on OK, and I'm just going to pick up the purchase order ID from here, and then overall status for purchase order, and then I can just say purchase order item positions, purchase product GUID which was sold, currency code, gross amount, tax amount, and net amount for the purchase. So these are all my purchase for my IT company, the sample IT company in the EPM model which we discussed in our third class of ABAP on HANA. Okay, so that's about my purchasing data. Now I will just save this data. Basically I don't want to save it now, but I will just proceed with the star join. Now I just go on the top, and that's my stars fact table. I'm just going to drag and drop our attribute view which we earlier created for the product dimension in the star join. I drag and drop it. Should ideally bring in the attribute view. Is it not bringing? Yeah, it's bringing. You can see it has come up. It's loading the columns for the attribute view, and then I'm just going to join the columns of product ID with the product dimension. So the node key should be joined. So product ID, here it is, and just join it with the node key in this. So there's a one-to-one relationship between product and the purchase order. So every item of the purchase is has to have a corresponding product information. Yeah. So that's about my join part. Let's go to semantics and mark the measures, because it's mandatory to mark measures as far as an analytical view is concerned. So I'm just going to come back and say measure. This gross amount is a measure. Every numeric column ideally is a measure. Okay, and default aggregation is summation. I can also, let's say, change an aggregation for tax amount to find out which product has got maximum tax incurred for my purchase from the channel partners. So remember the business scenario. Let me quickly again take you to the business scenario, the EPM scenario which we had discussed for this company. So this ITEIO is a company which has suppliers who supply the products to you. So you are raising a purchase order to the supplier, and they will supply the data, the products to you, and that product you will send it to your customers. Yeah, and you bill the customers with invoices, and you would get sales order from customers. So we are now getting sales order data and purchase order data both. We are joining it with the product dimension. Okay, that's the star join we are building. And then you see the supplier would charge you also for the product which you purchase, and they will also tax you for the products which you are purchasing from suppliers. So I'm calculating the maximum tax which was incurred by the supplier or from the product perspective. Okay, rest all the fields I will just consider auto update, auto assign, and all of them are marked as a measure. Fine. So I think we are done with definition of our view, analytical view. Click on save button. By far so good, and let's quickly activate it. So I'm going to activate this. So this is going to give me the data in terms of uh, purchase. So last view which we created, analytical view, was giving me the data in terms of sales, and now I'm getting the data in terms of purchase. So let's see, you can see also a tiny icon here which indicates it's inactive yet. You see, for the another view which we have, it's the tiny icon of gray color is not coming, which means that's active. Now you see completed with error. There is definitely some error. Let's double click and find. Now it says encounter the error in repository runtime, model inconsistency, alias currency code must be unique. So the currency code alias which we have it's not unique. So let me just check it. So you see there is one currency code coming from here, from our order table, purchase order table, and there's another currency code coming from the product table. So these two are conflicting in the system. So I will just go and change this currency code alias name, and just come here and change the name to _1. Okay, just I can't change it here. Just select this one. Okay, I'm unable to change that. Maybe just delete it and re-add it, or maybe the one which we are getting from the attribute view, I can't delete that one. Actually, I'll delete this one only. Go back, just go here and then click on delete, or you can just change the name here. I think we should be able to change the name here. We are not, but yesterday we saw the one which we added. I just say yes, and I right click and say add to output. And since now it says that already a join is applied on the star join, it now automatically changes the name with _1 into it. Okay, that's automatically done by the system. Let's reactivate the model. So I reactivate the model, and you can see it started a reactivation at the bottom, and this reactivation will then show me the final results. So I should be able to now analyze my purchase with respect to the each product. So earlier I was analyzing sales, now I'll analyze purchase. So you see completed successfully. Let's have a quick data preview. It's going to give you the data in terms of product dimension for purchase, all the purchase which you have. Let's go there and just quickly check the raw data. If the join works fine, then you see some raw data is being coming. And I also quickly go back and change my query, this time with respect to the purchase order tables. So I have my ABAP schema. I expand that. I go to tables, right click on the tables and apply a filter with SNWD _ all the tables starting with that, so that I can now go ahead and find the tables for purchase orders. So SNWD _ okay, and that's the filter I'm applying. In the meantime, I'll just remove I'll keep the product ID, but I'll just change. I think it's PO_I only, guys. We can use this directly. So that's my purchase order item table, PO_I, and the rest all the column names remains same. I can just simply execute this query to get the result per product. Yeah, so per product how much sales have happened. So it all, since it's an outer join, you see, so outer join is also giving me the details about products which I never purchased. Yeah, so you see, so HT1000, you see I did a purchase of 7,963 US dollar. I think the currency is USD. So that's the purchase which I've done for this particular product from supplier. Okay, and I think I already have very large amount of orders in hand for this particular product, which means I have not yet procured or now not yet purchased you know uh, the amounts which I have already in orders. You saw the last result, which was sales data, which was showing the amount of sales orders you have for this purchase. The HT1000 was too high, the value was too high. It was 29 lakhs or 2 crores 96 lakh 8,218 rupees, and you see my purchase value is by far is only this much. So that's the third high dimension which we will look at in our next example. So now let's quickly go ahead and see the data with the view. And I just quickly come to analysis again, drag and drop on access the product ID and then also the gross amount, and then quickly see the data. You see HT1000, if I just hover, it says 7963.48, and if you come here 7963.48, that's matching, which means your model is working absolutely fine. Okay, so that's how you can see, and you can also see the product which you are buying the most, which for which the most number of orders have been made is this one, this guy, this gentleman here, which is I think HT2000. This is the product which is the most purchased product by far in my company by myself, and its total amount is 36.73% of total purchase which I've done by far in my company from any supplier. Yeah, so that's the beauty. You can also quickly check, I guess, the name of the supplier. You can aggregate the data based on supplier, that who's the most priority supplier for my company. You can do that. There will be a possibility if I have company name, drag and drop here, and you see this is the company which is the most priority supplier for me. Talis Casa di Roma. This is the company from where I've done doing the maximum purchase. Also look at in the pie chart or a bar chart based on your need. So this kind of analytics you can directly unveil in HANA Studio after applying your or after creating your attribute views. Yeah. So that's my purchase data. Now, what would be the next assignment for you in your company? So after you have derived the purchase, total purchase data and total sales data, and perspectives are also coming up for you, but now your company want to do something more. They want you to do a real-time analysis on this data to find how my purchase versus sales for each product is doing. Yeah, every company would be interested in such kind of scenario. So what would be the scenario now? So by far this assignment is complete, where we have used an analytical view and give this result. But the next requirement comes, next big assignment which comes on our way is, now my company wants to find, so next requirement, company wants to find the purchase versus sales data. Okay, so they want to know how my purchasing and sales is doing from the product perspective. So which are all the two tables, or which are all the two facts which you are analyzing here? So if you look at, there are two facts, one is purchase fact and one is sales fact. So is it possible to include multiple facts as part of analytical view? Anybody? Can you have more than one facts in an analytical view? Yes or no? Is that possible or not? It's not possible. Okay, so that's why we will go to the third view, which is called calculation view. So what is a calculation view? A calculation view is basically meant for the same purpose. So when we need to include multiple facts as part of data model, we can go for calculation views. These views are processed by calculation engine in SAP HANA. Okay, and they are suitable for more complex calculations. As the name suggests, calculation view, they are suitable for more complex operations in the database. So let's have a quick look at the architecture of calculation engine, which is responsible for processing your calculation views. Okay, Let me just go ahead and show you the architecture for calculation view. What is there inside typically a calculation engine? How does it look like? So a calculation engine is consist of multiple things, and as you all know, HANA is meant for parallelization. So there are a lot of tasks which HANA will implicitly or automatically process in parallel. Okay, so how does the calculation engine process the data? What does it do typically to process your data? So what is the architecture of calculation engine? Let's quickly have a look at it. Our calculation engine. So this calculation engine has following components. To begin with, it has a SQL script. So now basically calculation views are also categorized into two parts. So one part is called as, you can design the calculation views also in two different ways. One is graphical and second is called SQL script. Within the SQL script also you have two categories: creating the calculation view using CE function. CE stands for calculation engine functions, and second is pure SQL. So which is nothing but SQL script, scripted or procedural logic. So these are all the broad ways or broad different varieties which you have to build or model a calculation view. Now it depends on your need of which option to choose from. There is definitely a difference in terms of performance. The performance of a calculation view is something which is a critical point, and sometimes if you do not get the desired performance, you need to switch between the options, and I will also tell you the reason why which option is better. So right now just let me tell you, the highest performance is gained by when you create a calculation view using SQL script CE function approach. Okay, you would get highest performance gain. The last bit of it, a last bit of database will be squeezed if you use CE function approach to build a calculation view. Second is pure SQL, which is SQL script, but again it depends how good you are in SQL script. If you are a bad SQL programmer, this is even worse. Okay, this is even worse. And the last one comes is the graphical way. So if you want multiple fact tables to be connected together and produce some result, and you're not happy with the modular approach, with the approach where you graphically model the view, and you're not getting the desired up to the expectation mark performance, you can go with scripted views, and they will give you somewhat kind of a better performance in terms of database operation. Why? Because the scripted view has a capability to perform or run these things in parallel. Okay, when you write a scripted calculation view, it has a capability, or HANA can perform these things much better in parallelization. Okay, much better parallelization is achieved when you use SQL scripted views. Okay, we will talk about SQL script. We will also talk about CE functions in detail when we will get into this approach, but right now we will start with the graphical based views. Now let's look at the engine, calculation engine. What is the architecture of calculation engine? I'll just move this on the second slide so I can draw that whole picture in one single slide. So it begins with the SQL script engine, or SQL script. So the input to the calculation engine could be an SQL script, or it could be a modeled logic. Yeah, right. So you can either give a model which is look like something like this. Yeah, this is a model actually. What you've done in the graphical tool is a model. So you will give input to the engine like a model, or you will give it in a SQL script. Now, the model, when you activate the model, it is compiled and stored in database. Okay, so you will not be able to run the data preview or see the output of the model until you activate, right? All the models which we were by far using, we were doing this step of save and activate. Until you do this, you can't see the data preview, right? But Did you did any save and activate for query? Anyone? Did you do a save and activate for query which you wrote here, which was giving the same data? Of course not. You only did it for model, right? So the calculation models are only created, persisted in the system once they are already compiled and checked. Compilation step means checking for syntax error, checking for consistency. All that is done, then only they are saved. But SQL code, SQL script based code can be saved, which you see here in this case, it is saved without compilation. Okay, without even compilation, and every time you run it, it has to compile the code. Okay, basically not necessarily if you have activated and stored it in a stored procedure, it doesn't need to compile. But if you're using calculation view using SQL script, it has to compile this because it's a code which you wrote and system has to compile it. So there is, it has to go with an additional process called SQL script compiler. So that these are all the two different input which can come and be fed to the calculation engine, and then from here the calculation engine starts. What is there inside this box of calculation engine? Let's have a quick look at it. So it has first of all something called a model optimizer. Okay, it includes a model optimizer which checks can can the queries can be executed in parallel. That's the model optimizer does. Can you run the steps into parallel? That's your optimizer does. And optimizer can do the parallelization better if it's a coded scripted view. It cannot do much of parallelization on a calculation model because the scripted code can be judged better by this model optimizer, and it can achieve better parallelization for us. So that's what the model optimizer does, and it's a rule based model optimizer which will decide if which are all the operations which can be performed in the parallel mode. Okay, that's the first part of it. That's the first part of this modeler. Then after modeler optimizer, there is a model executor who will finally execute the queries, execute the model. So everything is finally a query only, even though you have a model, it's a model executor which finally executes it and pulls the data from your database tables. From the real RAM storage, it will pull the data. And sometimes if you remember guys, you are actually giving different types of variables, right? So you are putting a lot of variables in HANA, like input output parameters, calculated values. You have put a restricted column. So all the intermediate results like currency conversion, stuff like that, those intermediate results will be stored in a buffer. So while you're doing calculation, there are some intermediate results which will be stored in a buffer. So that's what we have additionally in this. And then we have finally calculation engine operators also, because there are different types of operators which I will show you in calculation engine, like aggregate, projection, join. Those things you can do it, in the calculation views only. You can't do it in analytical view. So those calculation engine operators are also stored inside this execute inside the calculation engine. So that's also is one of the component of the engine what we have. Just also quickly put it in a better way. It looks nice if I do this. Okay, so that's what it will take help of. This executor will also derive the information about the operators, what operators have been used. And finally, once the data model is ready to be executed, to be prepared, everything is prepared, it decides now what is the final set. And this is the final set which now has to be given to the database to pull the result, and then it will provide the data to the database optimizer to further optimize it, or it can also give to the SQL script optimizer. Okay, so if I just do this, system will also send a call to this database optimizer and the SQL script optimizer. Now, if you see the SQL script optimizer and the database optimizer, are they part of calculation engine? Anybody? Are they part of calculation engine? The script optimizer and database optimizer, are they part of calculation engine? So you can see the gray color box. This is my calculation engine. This is the boundary. Okay. They are not part of calculation engine. And if I take you back to the old architecture also, where I showed you how the views are processed, you can see SQL optimizer is outside the calculation engine. Okay, it's outside the calculation engine, it's not inside the engine, which means if you write a SQL query which is processed by SQL optimizer, so if you are using scripted based views, okay, pure scripted based views, what happens? Anybody? If you are using scripted based calculation views, what happens? System has to, okay, system has to send the query to the SQL optimizer and ask SQL optimizer to optimize it and then execute it. Okay, so there is a communication happening within the HANA system between these two engines, the SQL optimizer engine and calculation engine. Hence, your performance will go down. Okay, whenever there is a data exchange, understand it very clearly. That is also a bottleneck for us in ABAP on HANA. If you are transferring the data between database and application layer multiple times, or large amount of data, it's a bottleneck. In this also, if you use a scripted based views and transfer the script, execute it, what happens is this executor cannot optimize the query itself. Okay, it can only optimize the models, it cannot optimize queries, so it has to send it to SQL script optimizer to optimize it and gets the query back and then execute it with the help of the another entity called row store or column store, executor. It will use that to execute. But there is a communication between calculation engine and SQL optimizer if you're using SQL script based views, so your performance goes down. That's the reason why we use CE function based views. That is again an approach of using SQL script only, but in this all the code will be written by ready-made functions provided by SAP HANA. So SAP HANA provides ready-made functions for common tasks like projection. Projection means selection of some columns. That's called projection. So it provides ready-made functions like projection, selection of columns, projection. This is one type of thing. So SAP HANA provide ready-made function for common tasks like projection, join. You do a lot of joins, right? To connect to data objects, to data tables or views, whatever you are using. Joins, selection, where clause, wherever you're putting where clause. Okay, so for all these different capabilities, join with an star scheme or join with a fact table. Okay, that's a separate special join if you're doing temporal join, for example. So that type of thing. Projection, selecting data from a column table. Okay, for all these common tasks like or doing union, doing aggregation, all these things, HANA provides you ready-made functions. These functions all starts with CE underscore. Okay, CE underscore they start with. You can use these functions and you can produce the same result what your model was producing. But the benefit of it is the calculation engine functions are always executed within the calculation engine. Remember, very important funda, folks. All the CE functions are implemented inside calculation engine and executed within the engine. They don't need to be, you know, pass the control. They don't need to pass the control to SQL optimizer. Not required. You don't need to pass the control to SQL optimizer, guys. It's very clear about it. That's the major advantage of using SQL script based editor with calculation function, CE function. You see, this is getting highest performance if you want highest performance. Again, there is a fight between these two. If you are a good SQL programmer, then you can definitely save a lot of time and get performance boost. But if you truly want performance boost, you should use this. This would then reduce a data communication which is typically happening between your calculation engine and SQL optimizer. That bottleneck will be removed if you purely use CE function. Remember guys, very important point, interview question, and very few people knows about it, because this is something internal to HANA. It's the architecture of SAP HANA, how HANA is designed. Okay, so within HANA, the simple answer, if somebody asks in interview why we should use CE function, not write direct SQL statement in SQL script based calculation column views, answer should be, if you use SQL script based calculation views, there is a communication which happens between calculation engine and SQL script optimizer to optimize your SQL statements. This would lead to an overhead on database, transferring the control back and forth between two different engines within HANA box and lead to performance bottlenecks. So that is the reason we should use CE functions, because CE function execution is local within the engine, within the calculation engine. It can perform the execution of CE function and drive the results. It doesn't have to send the control back and forth between two engines. Is that clear to everybody? I want yes or no. Or you want me to explain again? Yes or no? Is that clear? Why we should use CE function? What is the main purpose? Okay, great. So if it's clear, let's proceed. So we will now see approach to create calculation model, calculation view with graphical approach as well as with script optimizer. Okay, one answer says again repeat. Okay, let's take an example. If I write a query, okay, if I write, let's say, two queries in the system. So I come here, and if I write two queries here in the system, I say select star from order table, or select a star from product table, out left outer join order table on product id is equals to order dot product id. Okay, so this is my query, and then next query is where I'm using this result of the first query. I'm using this result and I'm just saying select only product id and sum of gross amount from previous result. Okay, and this previous result is something I store it in a variable. Okay, this is a SQL script example, guys. I'm giving a SQL script example. I didn't taught you yet SQL script, don't worry about it. Just understand, let's say, simple programming code where you obtain a desired result and declare a variable and store it. And now this variable you're using to apply an aggregation on top of it. When you write this query, what happens is, and if you give it to calculation engine needs to optimize it. How? It doesn't know. It has to send these two queries to optimizer. What optimizer does, it connects these two queries together and gives you a single query. It joins these two queries, not a typical database join, but it adds these queries so that the operation can be completed in a single database call. Okay, or it optimizes it to be, how it optimizes, instead of select star, it directly does this thing over here, and then it says group by product id. This is what your optimizer does behind the scenes. If you wrote this query, optimizer converts it to this query, because it knows that ultimately you're doing aggregation. So it will optimize your query automatically to a single query, so that this operation can get completed with a single database call in a much faster way. But to optimize this, you have to, or your calculation engine doesn't have this capability of the optimization. It has to send the query to the optimizer. So two queries goes out, optimizer optimizes and sends you one query back, and that you execute. So there's a call between engine, calculation engine, and SQL script optimizer. And you see the boundary of calculation engine, it's outside. See the boundary, gray color box. The optimizer is outside the calculation engine. It is outside. So there's a call between two different engines, isn't it? Whenever there's a call between two different engines, it's a performance issue. It will lead to performance issues. Okay. So what do? We can change this. So how we can change this? Our goal objective is to, what is our goal then? Goal is to now do something with which call doesn't go to another engine, and that something is use CE function. CE function, the beauty of these CE functions are they are executed within the engine itself, within the calculation engine. CE means calculation engine. See the name, CE, calculation engine functions, which means these functions are executed within the engine itself. For them, there's no optimization required. You don't need to send it to optimizer. So the call never goes outside your boundary. It can be performed within the boundary, within the engine itself. Hence, you would get performance boost. That's why we use CE functions. I will introduce CE functions in upcoming chapter. Don't panic right now. Okay. I will show you the purpose of using CE function in upcoming chapter. Okay. Right now, don't worry about it. Okay. So CE function, how, I'll just give you simple example. How does it work now with CE function? So you say CE underscore. The first thing which you are doing is a join. So you will call the SAP and says CE join. And then in this join, you will put your table 1. Oops, sorry. We'll put table 1, table 2, and then you will say join condition. That's it. Okay. Second function, after doing this join, you will say CE underscore aggregation, and you say whatever result you have obtained here. This is again a SQL script based code, which I will show you in upcoming chapter how to write SQL script. You need to understand basics of SQL script. So there's a declare keyword which I have to put here, and then you say result sum of, let's say gross amount, and you can also put where condition with some specific where condition if you want to put. These functions are purely executed within the engine. These functions doesn't need to pass the control outside the boundary of calculation engine. As a whole result, you get better performance. Okay. Because if you see this is already done by within the calculation engine. Okay. CE functions are within, there's no call goes outside the boundary. Hope this is clear this time. Why we should use CE function based approach to create calculation views to get better performance. Okay, so now move on. Let's create an example. What is the requirement now? So what is the requirement here? So requirement I think I already posted in the last PPT. Let me just bring it here. Now we need to see the two fact data, purchase and sales together, and want to finally analyze how my purchase versus sales of each product is doing. Let's go ahead and create now a calculation view. So now we have reached to the flow chart in the third level, level 3 in the flow chart, when we reach to the need of a calculation view. So now you can always cross check with this flow chart whenever you get a requirement in the company. Take a printout of this and put it on your desk. So you can show your manager, okay, this is my flow chart which I prepared, and you see according to the flow chart which the requirement fits into which flow. So you put a ball from the top in this pipe, wherever the ball hangs, that's the view you will use. Okay, simple funda. Okay, so in which case you will go with calculation views. So you will simply say calculation views. I will decide whenever there is a need for complex operation like union. I will show you what is union. There is a option called projection. Okay, whenever there's a need for these things, and also whenever we need to join more than, or when I need to get more than one fact in the output, we will use calculation views. Further on, this chart gets divided into two parts. Okay, if I just bring that chart here, now it will ask you one condition, how good you want the performance. So you will you will simply go with calculation view with modular approach. Modular approach means the way you are modeling by now, the graphical approach. This is called graphical approach or modular approach. Okay, if you decide graphical approach, after this I would say in the flow chart a rhombus, which is actually a condition. Okay, so if I just put it here, a condition like this, happy with performance, answer is yes, then you are done. If answer is no, what will you do? You convert that calculation view to a scripted calculation view. Use SQL script based calculation views. Okay, SQL script based calculation views, and in this most probable option which you should go with CE functions. Okay, you should know SQL script again to know little bit about CE function so that you can make use of variables. Okay, so that is what your flow chart should be on decision of which type of view to use, and very important interview question as well, in which case what to use. Okay, let's move on and create with a graphical way first to do this analysis between purchase and sales from the product perspective. I go to the HANA system. So I'll first now show you the algorithm for doing this analysis quickly. So what I'm going to do is we have the data. So let's take one set of data where we have the purchase data. Okay, so I just right now consider only two columns from each one of them to make it simple for us. Delete the column, and then I have, let's say, product data, and we have purchase gross. Yeah, this is, let's say, aggregated data, and then I have same product and I have sales gross. Okay, so I have these two gross amounts which I have product and purchase gross, sales and sales gross. So what I ultimately want is I want to join these two facts, which is one is purchase and one is sales, and produce the final data in a way that it will have in total three columns. So let me just, okay, oops, ruk ja, where okay, now I think I can insert a column on the right and say purchase and sales cross. This is what my company want me. My company want me now a perspective that for a given product, let's say I just put a product 1, I have done a total purchase of 1000. Product 2, I've done a purchase of 0. Product 3, I've done a purchase of 600 or 6000. Product 4, I've done a purchase of 500. Then I have PRD1 for which I already have some orders of, let's say, 600 US dollars. For product 2, I have an order of 300. For product 3, I have orders of, let's say, 0. Nobody is buying this. PRD 4, I have orders of, let's say, 6,000. So now my company is unable to judge today by system data how my products are being purchased and sold by my departments with respect to order. Now you see here critical problems. You see, there is a purchase which my company have done 0. I'm not purchasing anything. I already have an order for a product and I'm not purchasing anything, which means unhappy customers. If I don't purchase, I have a product which has a demand, which has already some order in hand, and I didn't even raise a purchase order yet for that product. It will lead to unhappy customer or a delayed delivery. On the other hand, you see there is a product for which there is no sales order. Okay, no sales order, no sales requirement, but I have done a purchase of highest 6,000 US dollars. That's a block of inventory. I don't have any order for iPhone X in the market, and I've purchased 50 iPhone X. I blocked my company money. I blocked the cash. And this cash I would have utilized to do some more better work in the company. This is a pure loss in a longer run, because iPhone X prices are going to dip down in the next year. On the launch of a new iPhone XX phone, the prices of current phone will go down definitely, and that will lead to losses in the company. See the business, guys, how the business will get affected. If you can drive such results on a single plate, you can definitely take good business decisions. You see here, there is another sales of 6,000 US dollars, which I already have 6,000 US dollar orders in my hand, and I just send a purchase of 500 yet. I did not even send an order for this. So the ratio is too high. This would also lead to unhappy customers. On the other side, you see a product which has a less demand, but I have high purchase which have been done. So are these department people, purchase department order, doing some forgery? Are they doing some forgery? Are they in touch? Are they getting bribes from my purchaser and buying the product from them, though there is no significant demand? Yeah. So these are all the kind of analytics which on the top level or a department level somebody would be interested into. If you are running a business, you will understand the importance of these things in the real business. Okay, that's about all about business. Modeling is just technical part, but it is all about understanding the business, guys. Okay, so now if I combine this data, I can easily drive. For PRD1, I have a purchase or order of 1,000 in my hand, but these people have just sent an order. I have order in hand of 600. That's a sales order I have, but I purchase unnecessarily 400 extra product, but that is also fine, acceptable. But on the other side, things which are not acceptable are also problems. So you see 0, 300. Then you have PRD3, and then yes, 6,000, but there's nothing, 0 sales. I purchase unnecessary, I'll block the company money actually. PRD4, 500, 6,000. There's a big order in hand already, but these guys are not purchasing. Didn't even raise a purchase order till now. Unhappy customers in future. And that could be because I have already invested with amount which I had into this product unnecessarily. So I will de-invest this and I would reinvest into this. That is the kind of analytics which can be really beneficial for me going forward in the company. Hope you all got the idea. So what typically happens, you got to bring the data for product column in the single product column from both the perspectives. So the product data will be coming from both the perspectives in a single this thing. So you would see, if I when I want the data to come to my system, I would be getting the data from here, and then this guy, of course, here. So from these two star schemas, I will join and build the new product. And then I will correspondingly pull the purchase gross values, and then I'm just gonna bring this sales gross values. Is that clear to all of you? I'll just change the color of the lines so that you will know this how the data is coming up. This is my product data, and this is my purchasing data, and this is my sales data. So you can see the perspectives now building correctly to produce this kind of analytics. Only calculation view can do this, because analytical views doesn't have capability to include multiple facts. Okay, let us go ahead in the system and do this. So I will go back to the system, and this can be done in multiple ways. Okay, first I will show you an approach which is join approach. And you see, to do the join, it's always better if you consider less columns. So first we do projection on the data, and then we do a join of this data which we have. So my projection means I only want product and gross value. I don't want other fields which I have in my model. You see, there are other fields which we have in the model, which the model which we created, analytical model which we created. You have a lot of fields like tax amount, net amount, yeah, supplier ID. I don't want all of that. I just want the data of product, because my analysis construction is all about product. So I don't want other properties to be part of my final result. Okay, since I only want perspective from product. So if you look at the semantic, and you can see the fields which you have, typically you have a lot of fields. I want just product ID, or probably the product text. If I have done an expose of that, I didn't do the expose of product text. Let me also expose in this also the product text exposure. So in the final output, I want to also expose the product text. Right click. I think it's already exposed. Fine. It's already exposed, no problem. So I would use product text rather than ID, because that's more helpful for the business to check rather than HT 1000, 1002 or something. So let's go ahead and create a calculation view. Right click, new, and just calculation view. And I say CV, and I say product perspective. Okay. And then choose calculation view and choose graphical. And you see scripted based is SQL script, right? I'm going with graphical approach. I'm not using any star join, because in that case you don't need your attribute views or analytical views. You can directly join the tables if you go with star join. We will not look at this example in detail. We'll just go with graphical approach with cube, and SQL scripted approach in the next session. So we'll choose cube, say finish, and this would lead to generation of my data. So let's go ahead and see this. Now again depends on requirement. So hope you understood the requirement already. In the PPT I've explained it. So now I will first, you see here, these are all the special operators or the node types you have in the calculation view. So I'll use projection. So I'll use two projections first of all, which means when I'm doing the join, I don't want to consider many columns. So I just do projection of my context. What is that I want typically? And then in these two projections, I will drag and drop my star schemas. So one is the purchase perspective, and one is sales. So I just do a purchase and drag and drop to the projection one. That's my purchase perspective. Drag and drop the sales perspective to the projection number two. So let me just go and use the sales fact table. So let it add, it will take a little bit of time. And then I'm also going to drag and drop the sales perspective, because remember, you got to minimize the data transfer. You see there are too many fields in your views, so you just reduce to some fields before we apply the join. We just tell the system to pull only few fields before you apply the join. That's a good practice if you want better performance. Not all the column data should be selected from database, only few columns and then a join between them. That's a good perspective. Also, you can change the name of this projection. So select this in the properties. You can come and say this is my all my purchase data. Oops, there's no space which you can enter. You can say purchase data, and then you select this one and you can say sales data. That's my perspectives. And now just quickly come on the left and just expose the fields from the projection which you truly need. Select the projection one for purchase, and I say I want only the product text to be exposed to the output, and the total gross. Where is the gross amount? Here it is, the measure. And of course we all know the currencies are in US dollar in this system, so we don't want anything else. If there is a currency conversion required, that's done at the analytical view level, so we don't need to care about it. Yeah. Then comes the next perspective on the right side, which is sales data perspective. Same thing I will do. I will expose from this my product text, and it's always better we also expose the product ID, because that has less data. It's not a big column. For to participate in the join, I'll use product ID. And then here also the gross amount, the product ID in the product text. I want product ID and then product text. I will just add these three. So these two are my projections. The selection of fields, first of all, I've done selected the fields of my choice from each of the view. Then I will apply a join, or first I will show you union. Okay, first I will show you union. So I will do a union. What is a union? Anybody? If I have a table A and if I have a table B, what would union results me? Anyone? What would be the result of the union if I have a table A and table B? Yes, A plus B, which is all the records of A and all the records of B. So if you look at your output, you want the output in this format. But do you know what union will do? Union will produce output like something like this. I will show you. So union will do this, and then union will do this. So this will be the output. Sorry, this will be the output from union. I'll show you quickly. I'm not able to insert a column. Yeah, now I think. And then you will get this. Get like this. This will be the output. When you do a union, this is going to be your output, guys. Okay, but we wanted this in this format. Okay, we wanted it in this format. So I will show you how to do this data in this format. I will show you that. Okay, so right now let's look at this output, and how to come to this output I will show you from the union. Now union is simply not checking anything between two tables, taking one table plus second table. It's always fast. Okay, if you do a join, that's not fast, because join has to check now data from first table comparing with second table. So union is always faster as compared to join. Remember, this is a tricky interview question. Which is faster, union or join? Your answer should be union is faster, because without checking anything, it will sum up two tables. Okay, that's your union. Okay, now let's go back. Do a union. I did a join by mistake. Let me just remove this guy, this gentleman. I remove it and just got this gentleman union. And I think it's just giving name as a join. I'll change it to union. See, the type is just union data. Yeah, and just drag and drop the relation from both of them, and then select the union. Sorry, I used join, guys. Sorry, I'm so sorry. You're right, I used a join actually. Delete this. There's another option for union. This is the right one. I selected join by mistake. Sorry. I drag and drop. This is my union. Correct. Now drag this from an arrow from both these tables here, and that's finally become your union. Let's select the union and change its property and just say union data. And now another interesting thing what you will do here is you now have to tell how the final data should look like. Okay, so that is told here in the target and the source. So you see, this is your source table, this is your target table, how your final data should look like. Okay, this is what you have to tell the system, how will my final data in the union will look like. Alright, ye kya hua? Okay, yeah, this is okay. So now you can see this button auto map by name. I click on the button and you see it's auto mapping the data. What it is doing, it is summing the gross amount from both the tables, but that's what I don't want. I don't want to sum up the purchase data with sales data. I want it to be depicted differently, right? So that's why I just kill this relation. I delete it and I just drag and drop the gross amount again here on the right side. So gross amount 1 is your sales data, gross amount is your purchase data. So I think we can also change the names. Let me just check if I can change the names. I think we can change it in semantic. So now you see the text can be combined, can be considered, but product ID also can be considered that same, but these values are different. So I want to consider them differently. Okay, so that's about the union. And finally you do an aggregation, connect this union to the aggregation, go to aggregation and you see this is your data. And then here you can specify which is your measure and which is your attribute. You can also then do a currency conversion at this level, okay, which you can also do it. Input parameter, restricted column, all these features are again there. And then you can finally add these things to the output. And then you see gross amount I'm adding as an aggregated column, product ID I'm adding an output, and this also as aggregated column. Let's change the column names if I can. I change the label here for the gross amount 1. This was what? Gross amount 1 was what? This was my sales data. Okay, so I'm just changing the names. Gross amount 1 is my sales total. Okay, and this was my purchase total. Come save this, come to semantics. You can see measures and the attributes are already defined. Fine, we are done. I guess we can go ahead and activate this and see the results. But it will still not get you the results as your company desire from you. Okay, let's click on save and activate first. At least see the data preview. Is it at least totaling up your gross amount for purchase and sales for each product with a union, which just joining these two data together in a single table, combining the data in a single table. Let's see this. I click on save and activate. You see it's at the bottom, it's running, completed successfully. And let's look at the data preview. I just go to the data preview and the raw data, and now you can see the data, guys. For HT1000, see, this was the required data we wanted. Actually it has summed up, guys. It has done the aggregation. I think you're getting the data in the desired format itself, because we have combined the text and the product ID already in a single column. So it is putting the data here properly, you see. So purchase of this product is 7,963, and there's total sales amount for which I have sales orders of this much. See, big difference, guys, huge difference, which means I have to invest more on this product. People are not doing their job. There's a lot of sales order, but purchasing have been not done according to that. Okay, on the other side, sometimes if you come down, you see there is a purchase requirement, but there is no sales requirement. Nobody requested this product, but my company people have already sent a purchase order for these products. See, question mark means no data. Okay, no data. See, but that's okay. That's a considerable amount. 641 US dollar is nothing. 92 USD nothing. So that's okay. So you can see the differences, and see this one, 310 and this, the quantum of difference is too high. I have very few purchase done for this. There are huge amount of sales orders for this product. Purchase versus sales data, you see, and there are many of them for which I've done it doing purchase, but there is no sales I'm doing. On the other side, there is no purchase being done, but there is a lot of sales requirement. Can you see this? In fact, there are many of them. There is a sales requirement, but my teams are sitting. They are not able to judge what to purchase from suppliers. Or I can at least go and ask the question, why are you not sending purchase for these products? See, there is a sales demand. Yeah, there are sales orders, but you're not doing your job. You can also calculate a calculated column to calculate the difference between them. So come back, insert a calculated column, new calculated column, and then it's going to be a measure once again. And I say difference, and I say decimal, and I just use 21 and 2, and then I can just put down difference between purchase and sales. So I can say what is my sales total minus my purchase total. I want to know that. Okay, what is the difference between these two? Which means I have huge sales demand, but you guys are not doing enough. And if it goes in negative, which means you are unnecessarily purchasing something for which there is no demand. Very clear indication to my team. Okay, click on OK, and this column is added. Let's activate the view now, and you're gonna see that in the data preview in a minute, this calculated column. So these are all done at the database level, which you earlier used to do in application layer. It's pure into HANA DB now. You can see the time you will save pulling the data and doing all this in the application layer in your ABAP system. Loop out, get select star from DB table, pull all the data in an internal table, and there you are doing all this. Yeah, but now you're doing it with an easy approach in data models directly in HANA database. Let's look at the result. You're gonna get your new column. Oops, it's not coming here at least. Just again click on data preview to see the result. Go to raw data, and you see now the difference, guys. Purchase versus sales. See the difference. Is that what I wanted? Yes, that's what I wanted. Now I know who is doing good, my purchase department or sales department, who is honestly doing their job. Amazing. That's about my calculation view with graphical mode with a union operation. Now suppose if I'm not experienced with calculation model and somebody teaches me that union, and in fact this happened, guys. One of the trainer, I was checking some videos. According to that trainer, I will not name the trainer, but according to the trainer, the union and the join are same. They more or less produce same data. No, incorrect assumption. That trainer have not spent his time in practical use cases. Then union and joins are different the way they processed. So here you see it works like outer join. So if you do a union, it will give you all perspectives, which means where there is a purchase data, it will give you, even though there is no sales data, it will still give you that record. See 1601. But if I do a join, it will only give me the data where the record exists both in purchase table and sales table. Remember, guys, I will show you now the one with join. You will see some difference in the data. These perspectives you will never will be able to build when you use a basically a join. Now also, if you want to replace this question mark with a zero value, which will look a better thing, if you also want to export this data later on and do some calculation in Excel sheet, you can actually drive it from a text file or HTML file, all that. But if I don't want this question mark or null value to be exported, I want a zero to be exported, I can do that. So what I can do is I just come back, go to our union data, right click here, say manage mapping, and I say purchase data constant value. If it is null, make it 0, make it 0. Okay, click on OK, right click same way. In case of purchase perspective, the sales data, if it is null, make it 0. Just do this, activate it. One of my misunderstanding was also clear today. I was thinking it will just join the data like this. It didn't. Actually, it has aggregated the data based on product ID, and product ID, wherever it match, it has aggregated. So it has put 1600 here in the parallel. It has done the aggregation. So that was my misunderstanding. It has done it. Now here there is no data, null. So it has put a question mark here, and then it has put 300. So it has already produced the desired result. What I'm doing now, this null value I'm replacing with 0. That's what I'm doing. So I just come back, which I did, and activated also. Let's look at the result. You should now see ideally 0 instead of null value. Let's go to raw data. You can see 0, guys. Here instead of null value, you see 0. Okay, that's better. Okay, now let's also quickly do some analysis. Want to do that interestingly. So I just drag and drop, and I can also see purchase versus sales in my company, how it is, how these two measures are doing competitively, the purchase versus sales. So you see the purchase is in blue color, which is comparatively very low, actually very low, and my sales is very high. I don't even see that purchase bar. Okay, I don't even see purchase bar because the dimension for my sales is too high actually. I don't even see that comparison, and I think that is because of this product, this guy here. It's huge. Okay, I can't see that. Maybe if I can see here, you see it's showing purchase versus sales in a pie chart. I'm not able to drive it because properly, but you can see the data over here, and there's a possibility to save it in different files. Okay, HTML output, I think we can see this is a HTML columnar output, grid output also you can see. So all that you can see it. That's also the nice feature of HANA. So that's my purchase versus sales calculation view with a union. Let's do it with a join, but you won't get the good perspective when you do a join, because then it would ask you join condition, and of course you can see here the join condition is going to be your product ID. So in that case you would miss out on some perspectives. Okay, so let's quickly create one calculation view with join. Right click and create a new calculation view. But remember, this is not the exact output which company expect from you. So better you don't do using a join in this particular case. Some cases you may want to use join based on requirement. Now you know the difference between them. So calculation using join, and graphical once again, finish. Now if you don't, you can also avoid doing this projection, guys. So if you think projection is mandatory, it is not. I will show you now without doing projection at all. Okay, I just did it because I wanted to do it optimally. And optimum ways, you first do a projection so that you don't lead to select all the columns which are even unnecessary. Ultimately you wanted only product perspective, so that's why I did projection. You can also do it without projection. Just drag and drop both of your data source, which is purchase data source, and then of course my sales data source. Let it come, it's taking a little bit of time. And this sales data source. So no need of doing projection, but remember this performance will degrade, because now you ask the system to first pull data for all columns from both the views. So your performance will go bad actually in this case, little bad. Okay, then do a join. I want to join based on product ID, both the perspectives. So I just add a join here, drag and drop once again the lines connecting to it. Actually it is making part of join itself, and just come on the right, just join these two facts. So now you can see I have two facts together. That's real calculation view. More than one fact being included. and just do a join based on product ID. It's product ID. Here it is. Done. And just double click and you can see it's done. The join is done. And now it makes it quite complex for you when you're doing the mapping. So if you go to aggregation, just drag and drop this over there on the top. And you see a little warning over here. Why it's coming? Warning. Ideally it shouldn't have come, because I think we have not specified the mapping. And I see it has actually put everything over here. Sorry. So where can I give actually the mapping of columns? I think that was something which I wanted to give. Maintain comment. No, it's giving me some warning. Ideally it should have given me the same interface like I saw earlier while I was doing the aggregation. So maybe I'll just use projection only right now, so that I can see that kind of aggregation which was earlier visible to me. Move my sales to projection and move my purchase also to the projection. Okay, I can't do that. I have to remove this. Because I'm not getting that perspective in studio here to merge the columns, basically, that I'm not getting when I'm not doing a projection. Okay, that perspective of merging of columns I'm not getting. That's why I'm just using projection now. So drag and drop. Both of them have come. Let's go to this projection and specify which columns to be exposed finally. So I want product ID, text. This time I'll also use company name, and then I can just use my gross amount. And then come on the right side and just once again use the product ID, the gross amount, and then of course the company name I want and text I want. Sorry. And let's do the join this time. So join is something which now expect you to specify column. And when you do that, you can see now here both the tables, and I have to connect them. I do the join between the product IDs of both the tables. So that's what will be my join condition. And it must fulfill now. So it will never give you result where you don't have a sales data or you don't have a purchase data for a product. So it will give you always an intersection. Remember guys, join, it will always evaluate. So it will only give you data provided that you have sales and purchase both data available for product. That's how your join will evaluate. Click on OK and go to aggregation. So that's about the join part. We are done. Let's go to the aggregation. Okay. Why am I not able to see that option of joining the other columns? It's giving me a warning here. Auto layout. Okay, right click and maintain comments, remove, replace, export diagram, data preview, expand, collapse. There is an option the way we did it last time for union, where we selected the columns in a view and drag dropped it, right? That option is not coming. Add to output. Add to output. Okay, actually it's just doing this, and then I have got this aggregation over here. Sorry, I just remove the text. Okay, maybe these common columns I'm removing it, the company name and stuff like that, and just giving the sales data. I think from where it is coming. Projection 1 is my sales data. So projection 1 gross amount is this one. Yeah, so that's my sales value. And then I have this purchase value. Okay, purchase gross. Let's keep the naming convention same. And then we have a join, of course. So that part is done, and let's come to aggregation. So this is all my data. I have to also now find out what is my um, basically what is my measure or my values. So that we will do it. We will right click purchase go gross is aggregated column, sales cost aggregated column, and of course I don't want this guy also in the output, and I just want these three as my attributes output. Okay, we save this, and that's a join based condition. Now let's activate the view and see the results. So now you're going to see the results where precisely you have data in both the facts, both sales and purchase. You have data from both sides because you applied a join. You're going to see the data only from both sides now. So it's running. Let's see the final result, what it produces. And the gross, it will of course create an aggregate by summing up the values. You can also use, instead of some other aggregates like max, if I want to see for this product what is the maximum amount of order I've got and what is the maximum sales order or purchase order I've got, I can do that with the maxed aggregate functions also. Let's look at the data preview. We are done, successfully activated with the join condition this time. And you would see the data preview over here, and you can see same data preview, but this time you won't get any item with zero or question mark. You see, you're seeing less products. The last data preview which you had, where was that? Here it is. You okay, not this one. I think we have removed it. Let me show this again. The last data preview, which was with the help of that, you will see you were getting in that case some zero values, the products for which there is a purchase but there is no sales. But now here you won't get HT1095. If you come here and say add filter product ID HT1095, you won't get it. So it won't give you clear perspective. Remember, it won't give you clear perspective. There's no data HT1095. It won't give you clear perspective, guys. So, and it's also time consuming because it has to now evaluate a join between two star schemas. Is that clear to all of you? Why it's time consuming? So which is better? Which is a better operation when you're building a calculation view? Anyone? Which is a better operation when you build a calculation view? It's of course it's a union operation. It gives you all perspectives and it's faster because it doesn't have to evaluate anything. Okay, that's the main importance for this. Is that clear? Any questions about calculation views in the system? How does the calculation engine works? Why we should go with CE functions? There's a question, can we achieve functionality of analytical and attribute view by using calculation view? Yes, of course you can, but idea is you should not, because calculation view is again used to do complex calculations, uh, especially evaluation or joining multiple fact tables. You can achieve same functionality, even this also you can achieve with in this you cannot achieve with analytical view, of course, but if you have a single fact table, even attribute view can be used, and that's what exactly I will show you next. We will use our OIA example to build all these things. Okay, we will do that, but before that let me start with introduction to SQL script, and I will show you how will we create CE function based SQL view, and then we will get in little deep into the SQL script programming so that you will be able to build AMDPs also with that knowledge. So that is what I will start now with. Introduction to SQL script. Can we see these views in SE11? Unfortunately, no, still not. We have to create a view proxy to consume them. Okay, let me then show that first. How to create a view proxy to expose the available views in ABAP system. So for that, I need to quickly switch to my Eclipse once again. So let me just on my Eclipse and connect to my ABAP on HANA system, my ABAP system from Eclipse tools, ADT tools. And that's only possible when you do it with ADT, ABAP development tools. But you can see the views in HANA schemas. So let me quickly show you. If I double click or if I go to the view definition, which is here. So this is my view definition. I double click on the view definition and you can see view properties. You can see this is the view name. This is the database view name which has been created. Still you can't see this view in ABAP system. If I connect to our ABAP system, let me just try doing that. Right click, get the properties, get the IP address basically. This IP address. I just use my SEP logon to connect to my ABAP system in SC11. Maybe SQL script will start with the next class, guys. Let's quickly see how to create a view proxy now in the system. Click on OK. Just connect to my ABAP system and see if there is a value or view called cvcal join something. I connect and go to SE11. In the meantime, also it's starting my Eclipse. I guess yes, it has started my ABAP on Eclipse. Let me switch to ABAP perspective. Just come here and I just search for the view. Okay, and I say what was the view name? Just go back. It's cvcal join. View cvcal join. You see, it's not there. Okay, I just search for star cal or star cal underscore join, star calculation view join. It's not there. Okay, so now we create a view proxy. What is a view proxy? If you have a HANA view in HANA database, so that's your again 3-tier architecture. This is your database layer. And then you have a data artifact, which is nothing but your data model. So you have your data model in here. Okay, this not used to so much. So this data model could be your attribute view, calculation view, analytical view, whatsoever you call it. That's your data model. You have it. And this data model you want to now expose to your application layer, your ABAP layer. Yeah. So for that, HANA or SAP NetWeaver 7.4 SP2 onwards, there's a feature available called View Proxy. So any available data model in SAP HANA can be accessed directly via ABAP using concept called View Proxy. Okay. So we will create a View Proxy in ABAP, which would then connect our HANA database. That's what we will be doing, to expose it to ABAP. For that, you cannot do the view proxy creation directly in SAP GUI. You have to use ABAP on HANA, ABAP development tools on Eclipse. So I quickly go back to my Eclipse, switch to ABAP perspective and quickly add my project. I also just want to delete these guys. They are just leftover garbage of my Fiori batch. Just delete them and then quickly add new my ABAP project and then just select my ABAP on HANA system. Say next. Provide my credentials. So this is also covered in previous batch. Those who are newly joined yesterday's class and today's class may not know what is that. Is this is called ABAP development tools on Eclipse. It's already been covered in my third session on ABAP on HANA. Please look at the missed classes videos. You will get to know what is ADT tools. So I've got it added now, and now I just have to create new. Right click on my package, say new, other repository object, and I say view interface view, no, selection view. I will delete it. FSI view definition for search service interface view. I think we will use this. I'm not sure. There's an option here. Yes, I think dictionary view. So let's double click on dictionary view. Provide a name. So I say CV underscore. Um, what was the name in HANA? We will keep the same name. So it was CV underscore product perspective, or CV cal join. Let's say cal product data, or SP data. Okay, CV cal SP data, and I say external view here. And now I can choose and browse my HANA database views. There you go. It has opened all the list of views in HANA. And the one which we have in database is CV product perspective. I just put it here, CV product perspective. There you go. Click on OK. It will connect to HANA database view and create a proxy view in SAP ABAP system. It will create a proxy view, guys. It means it won't persist things. It will just create a proxy, a channel, so that you can talk to that. So that's my view name. And specify the field description. We have forgot to give that. So just say sales and purchase perspective for products. And I say next. And if you give a productive package, you can essentially give a transport request. Now there is a catch, guys. The catch is, if you create a HANA view, which is nothing but a data model, it will get logged. How do you ship them to production system? This is your dev system. Okay, are you clear, guys? What am I talking? Development system. Who don't understand the development landscape, please tell me in the chat window. Development, production, quality. Who don't understand? Just let me know quickly. If you say no, I will consider you don't understand. Who don't understand development, quality, production? What is a development system? What is a quality system? What is a production system? Say no fast. If you don't understand, say no. No problem. I'll explain you quickly. So everybody understand, fine. So I go with that assumption. So if you are planning to now deliver these artifacts to development, from development to quality in production, you got to transport them, right? So in HANA, we have a concept of delivery unit. Delivery unit is an object in HANA, just like a transport request, to transport your objects of HANA to the quality and the production system. So in HANA, you have to create a delivery unit. And the view which you created should be added under this delivery unit. And once you release or ship this delivery unit, it will release, or it will transfer all the artifacts which you have in your system to the quality system. So in HANA, we have a concept of delivery unit. So you lock your view which you created in a delivery unit now. Is that clear? That's what you do. In ABAP, what do you use? What do you use to transfer your objects to the quality system and production system in ABAP? Anybody? What do you use to transfer your data? CTS. Yes, absolutely. Transport management system, CTS option, which is nothing but a transport request. Okay, you will release a transport request. Okay, that's what you use in ABAP system to transport your data. Now this is your dev, let's say. Okay, this is your development system. Now I created a view proxy on top of a HANA data model in my development system, right? Are all of you with me? We just created a view proxy based on a data model which exists in database. And I created this view proxy, which I'm doing it here. And I just logged it in a transport request maybe. So I just say next. Why it was giving me some pop-up. So I will lock it in a transport request. When I release this transport request and it reaches to quality system, what happens? It has reached to the quality system now. This is your quality. What happens? Anybody? It will fail in QA. Perfect, Naganjana. Perfect answer. It will fail in QA. Now you all must be wondering, Anubhav, why will it fail in QA? Because the moment this object proxy, view proxy reaches to the system, system will activate this view proxy. When system activating the view proxy, it tries to find this data model in HANA DB, right? It tries to find this data model on top of which this view proxy was created in the quality system. Did you release your delivery unit? Did you release your delivery unit? Anybody? Did you release your delivery unit? Yes or no? I want to hear. You did not. You just release your ABAP transport. It tries to activate this view proxy in ABAP system. It doesn't find the corresponding data model, information model. I would precisely information model, your view, HANA view. What happens? Transport will fail. So this is the biggest disadvantage of consuming HANA artifact as a proxy object in ABAP, because then you have to synchronize the transports between HANA and ABAP. You have to first send this delivery unit and then send the ABAP transport, or use a concept called ABAP transport, ABAP HANA transport container. Lock the transport request as well as your HANA delivery unit in this single container and release this guy. This is an additional overhead, and people were doing it, the everybody was doing their own style. Some people were releasing this, some people were creating this, locking it and releasing it. People were not following it properly. This has become a challenge over a period of time, and lot of companies have complained or sent tickets to SAP saying that it's not working, and then SAP has to go and explain everybody ki yaar isko pehle bhejo, then you should first you send delivery unit, or then you send your transport, or lock it in an ABAP HANA transport container and send that together with everything. So this has become a haphazard for companies when we use this approach. That's why the concept of CDS view was introduced, because in CDS view you don't have now HANA database object. You create a CDS view in the ABAP system. Okay, you create a CDS view in ABAP system, and when you hit activate button, the activation button will create a view inside HANA database automatically. Okay, it creates a view in the ABAP in HANA system automatically. Now what happens, since you don't have to synchronize, no delivery unit required, you just release the CDS view. This CDS view reaches to the quality system. No dependency on any object. The moment system ABAP system activates the CDS view in quality, it creates the corresponding HANA view in the database. Is that clear to all of you what is CDS view? Now some part of CDS view, not the whole CDS view concept as such, but some part of CDS view, why CDS views are better as compared to the view proxies. So view proxy concept was, it's still there in the system. Okay, nobody had removed it, but the problem with this is synchronization of your transports, synchronization of your database and ABAP objects separately has to be done or has to be managed. It's a headache on developer. But when you use CDS view on activation, it creates the database view automatically. But what if you already have information model? You can still use this technique from NetWeaver 7.4 SP2 onwards. You can create, NetWeaver 7.4 SP2 onwards, you can create view proxy or the proxy objects. With NetWeaver version 7.4 SP5, you can create CDS view and then release them, and they will create on activation database objects automatically in the target system in the database. You don't have to worry about transports. Is that clear to all of you about what is brief about CDS view, why we use CDS view, not view proxies? Okay, so let's come back to Eclipse. Test objects cannot be created in foreign namespace. Okay, I should use a Z name before this. That's very important. And say next because I'm using local object temporary package, and say finish. This would create a view proxy now for me in the ABAP system, and I now can consume the data which I have. But remember the problem, guys, that is the biggest problem: synchronization. If you lock it in a transport request, make sure your HANA delivery unit is sent first to the quality, and then your view proxy should be released, or you use HANA ABAP ABAP HANA Transport Container HSTC. I will show you that also a little bit in the next session, how to use that, how to use delivery unit also. We'll see that, a brief introduction, just a transport, nothing much. Now, sometimes it may also happen that once you created this, now you go and change your view in HANA. So now I go and change this view in HANA. Okay. What will happen? The structure will also mismatch now. So you created this view proxy, fine, good. You released everything, everything reached. Now you change this information model. What will happen? They both gone again out of sync. Correct? They will both go out of sync now. So how do you synchronize this now with this new changes? So there's little tiny button in ABAP on HANA here called synchronize. If you change something in your view, you can use the synchronize button to pull the latest information from HANA system and update your ABAP view. These are all the overheads which you have with proxy objects. Is that clear to everyone? Very good question you asked, how to use it in SE11. Now you can use it in SE11. Let's go. Same, I will do an F4 now. Oops, why am I not able to see that here? Maybe I'll just activate this. Didn't I activate it? Let me activate it. Okay, got activated, I guess. Let's quickly see the data preview here. Okay, not CDS view. So source code library, dictionary, yeah, dictionary, views, and I see my ZCV cal SP data over here. This is there in ABAP system now. Let me double click and just right click and do a data preview. You can consume this in ABAP system now. You see all the data have come to ABAP, and this would take less time as compared to what you were doing earlier, writing select query, pulling the data, doing operations. You can directly consume this view and fire a query on this. Okay, now why is that not visible in my SE11? Let me check. So I think the problem is the name cal underscore sp. So I should use cal underscore sp star, press F4, and voila, there you go. That's my SE11 view created. It's a proxy object to HANA database. It's a HANA proxy view. I can view the data now here in my ABAP system coming from HANA directly. You see, it's not displaying very well, but you can fire a direct select query now to display this data. Let me do that. Write a quick report. Let me use ABAP development tools, user report program, new ABAP program Z, consume HANA view. Okay, HANA view call and say finish. I'm just writing an ABAP report now. I can directly consume this view to print some results. So let me just show you the total purchase data per product in the system. So I just say data ls product, type this and select star from ZCV. Okay, full name, simple. Select star from this into table lt prod, and then I just say loop at lt prod. So if I do same OIA scenario using these views in HANA, I would save the time. I'll surely show you performance improvement as compared to the report and processing which you have done earlier, guys. I will show you that. LT prod, I will declare it type table of, and then I will also quickly, if you all remember our inline data declaration, guys, this was our inline data declaration, and ls prod, I will just show you writing this data. And whenever it doesn't have a native support, it will open the SAP GUI for us. I just use the text, and then I will show you the purchase total. And just click on save. Why it's giving me an error? No error. Okay, good. I'm lucky. Activate it. Many times, you know, example doesn't work when I'm demoing it, when I'm showing it in the class. But when I do it, alone, when I'm alone, these things works. It happens with many of us that when you are giving a critical demo, your program doesn't work. But when something else is happening, it works. So you see now the product name and the values are now being displayed over here. It is much faster, and you will see this result when I do the OIA analysis in the next class. Our open item analysis, will start with that, with all three type of views, and I'll show you real performance improvement, real real metal you will see in the next class. But the problem also you understood, this is an important point. 100% interview question: why should you use CDS view over view proxy? Two challenges: one is the transport, another is synchronization of database and ABAP objects, because just a proxy object. 100% interview question. This is ABAP on HANA, guys. This is ABAP on HANA. Hope you enjoyed today's class. Have a nice day. See you on next weekend. Goodbye.